Find the derivative of y equals f of x times secant x, then evaluate y prime of pi over 6, where f of pi over 6 is a negative 3, and f prime of pi over 6 is a 5. Y here is the product of two functions, an unknown function f of x, and a known function secant of x. Since we have a product of functions, the derivative will involve the product rule. So y prime, or dy dx, will equal product rule. Derivative of the first, we will call that f prime of x, times the second left alone, secant of x, plus the first left alone, f of x, times the derivative of the second. The derivative of secant of x is secant of x times tangent of x. So there's our derivative, y prime or dy dx. The next thing to do is evaluate y prime of pi over 6. Y prime of pi over 6 means to plug a pi over 6 in for each of the x's. So we will have f prime of pi over 6 times the secant of pi over 6 plus f of pi over 6 times the secant of pi over 6 times the tangent of pi over 6. So this is going to equal, well, f prime of pi over 6 and f of pi over 6, those will be determined by this information over here. F prime of pi over 6 is a 5. Now the secant of pi over 6 means 1 over the cosine of pi over 6, so 1 over the cosine of pi over 6 is a root 3 over 2, plus f of pi over 6, which is a negative 3. Secant of pi over 6, again, is a 1 over root 3 over 2. And then the tangent of pi over 6 means the sine of pi over 6, 1/2 over the cosine of pi over 6, root 3 over 2. Now I'm going to take each of those fractions in parentheses, reciprocate, and multiply the denominators with the numerators. So that will give us 5 times 1 times 2 over root 3 plus negative 3 times 1 times 2 over root 3 times 1/2 times 2 over root 3. So that will give us 5 times 1 times 2 over root 3 will just be 2 over root 3 plus a negative 3 times, again, a 1 times 2 over root 3. And then for this other multiplication, the 2 in the numerator and denominator can cancel before the multiplication, and so we will have 1 over root 3. So the first term, we have 5. We can think of that as 5 over 1. Multiply the numerators. 5 times 2 is 10. 1 times root 3 in the denominator is root 3. The second term, we have a negative 3 multiplying. Let's multiply the numerators. 2 times 1 is a 2. And then root 3 times root 3 is a 3. And these 3, since we have 1 in the numerator and denominator, can cancel. And so we will have 10 over root 3 minus 2. Now it is possible to get a common denominator between these. It'll be a root 3. We're going to multiply this by root 3 over root 3. And that will give us 10 minus 2 root 3 over the common denominator of root 3. So there's one way to write that result. Now since we have a root in the denominator, it's also possible to rationalize this. It's not necessary to do that, but it's possible to do that. So let's write another version that this might be by multiplying it by root 3 over root 3. In the numerator, distributing the root 3 in, that'll give us 10 root 3 minus 2 times root 3, which will be a 3. And then all of this will be over root 3 times root 3 in the denominator, which is a 3. And so this can be written as 10 root 3 minus 6 all divided by 3.